So let's continue looking at some different practice problems for determining if a number is rational or irrational. And remember the definitions. A rational number, it has the word ratio in it. That is a number that can be written as a ratio, or it's a number that can be written as a fraction. So you can think of rational numbers as fraction numbers, and irrational numbers, because it has the IR in front of it, that negates it. So these are not fraction numbers. So irrational numbers cannot be written as some fraction, a over b, where a and b are both integers. They're both whole numbers. So with this example problem, we have a decimal. And remember, the bar above it just means that the 6 is going to repeat forever. It's going to be a repeating decimal. And the general rule is that if you have a decimal that is either repeating or terminating, that these are going to be rational numbers. But let's think about why that's true. So as an example, before we get into this specific one, if we have something like 0.21, so this is what we call a terminating decimal, since it is ending. Now, this is a fraction. This is rational because think about it. The 2 is in the tenths place. The 1 is in the hundredths place. So we really have 21 hundredths here. So this can be rewritten as 21 over 100. So any decimal that terminates can be just rewritten as a fraction depending on what place it's in. So something like 0.1864, this is this is the thousandths place, since this is the hundredths. And if this is the thousandths, then this is the 10,000ths place. So this can be rewritten as 1,864 10,000ths. So you can rewrite decimals as fractions where you have some power of 10 in your denominator. So if it's ever terminating, it's definitely a rational number. But if it's a repeating decimal, it's a little bit trickier to convert it to a fraction. So the technique or the trick is to start with your number, 6.6 repeating, and we're going to let it equal some letter. Let's call it A. Now, since this is in the tenths place, we're going to multiply A by 10. So 10A, basically the decimal will just move once over. And remember, the bar means we can write as many 6s as we want after that, and you can't extend the bar since technically 6 is repeating an infinite amount of times. So sometimes it's helpful just to extend it 1 or 2 or however many places you need. So multiplying by 10, like I said, we just move that decimal once over. So this becomes 66.6 repeating, since the 6s will still continue forever. Now, to figure out what this is as a fraction, we essentially need to cancel off the repeating part. So we're going to take 10a, 10 times our number, and subtract our number from that. So essentially 66.6 repeating minus 6.6 repeating. And let's set this up as a traditional subtraction problem. So we have 66.6 repeating, and we're just going to line up the place values. And so 6.6 repeating. Now, after the decimal, all of these 6s are going to cancel out because we're subtracting here. So after the decimal, we're just going to get 0. So when subtracting 6 repeating minus 6 repeating, you can think of that as just 0. And the decimal point carries down, and 66 minus 6, that is just 60. So we found that 10a minus a is just equal to 60. And let's simplify this. So 10a minus a is equal to 9a. So 9a equals 60. So solving for a, we get 60 divided by 9. And that is our answer. That's what 6.6 repeating is equal to. Now, if you want to just double check, put this as a mixed number. So 9 goes into 60, while it goes into 54 evenly 6 times. and there are 6 left over. So that would be 6/9. Or simplifying, we have 6 and 2/3. And 2/3, you might remember, is commonly written as 0.6 repeating. So hopefully this does make sense, but you need to use this trick to convert it to a fraction. And this trick, you have to modify it a little bit when you have more decimal places, but this trick will work for any repeating decimals. So if the decimal terminates or if it's repeating, then you know for sure that it is a rational number.